So we will see about selection sort today. Um, of course, there are different types of sorts. Selection sort is one of the easiest sort. I'll take a simple example. Basically, 1, 5, 3, 7 and 4. Okay, how it should look like if it is sorted? It should look like 1, 3, 4, 5 and 7. Correct? It should look like 1, 3, 4, 5 and 7. In selection sort, there is only two steps. One step is iterating each element in the array with I plus 1th element. Basically, if I took first element and I will compare it with all the remaining elements, and I will keep on adjusting the minimum value between these two, and I'll compare the next value with the new minimum, and finally I'll swap the ith element with the new minimum. If the ith element and the new minimum are same, the swap will not have any effect, otherwise it will be swapped. Okay, think about it. In this case it will look like initially I1 it will look like this 1 5 3 7 4 in the first step, and in the second step it will look like 1 3 5 7 4 in the next step 1 3 4 5 7, and the last step uh, 1 3 4 5, sorry, 1 3 4 will come here, 7 will remain here, 5 will come here, 1 3 4 5 7 in the last step. Okay, 7 5 and last step it will be 5 7. Okay, how will this algorithm look like? Initially I will be 1, we will do it all the way up to n minus 1, which is this element, because when I'm comparing this with the last element, if it is smaller I'll swap, so I don't have to do it with for the last element because there is nothing to compare with. And at every time I'll keep the new I min equal to I. I'm keeping this as my, I'm assuming that the array is already sorted. That's what I'm doing. I'm assuming that the array is already sorted. Now I'm doing this comparison for all the elements which are I plus 1, I plus 1 all the way up to n, for all the way up to the last element. Okay, I'm doing this for all the element from I plus 1 up to n. Initially what I'm doing, if a of j is less than a of I min, then update my I min index as j. So basically what I'm doing, if my let's say like 1 is less than 5 is less than 1, I'm comparing for each element, I'm comparing, and then I'm making the new min as the newly found lesser value. Okay, in this case first iteration everything will be false because I min is already smallest, so this will always remaining the 1, so the final swap will be 1 will be swapped with 1, so there will be no effect in that. Finally I'm doing a swap of I min comma I. Okay, I'm doing the swap of I min comma I basically from the array. So think about it. For the next one we will check for 3 less than 5. When 3 less than 5 it will become 3 is the new I min. 3 will be the new I min. Now we will check 7 less than 3. It will be false. So 3 will still remain as the new I min. Then we will go to the next one. We will check with 4 less than 3. Still it is false. So 3 will remain the new I min. So we will swap 3 and 5. So now it will become 1 3 5 7 4. Now in this case we are starting with 5, so we will check 7 less than 5, it is false, so 5 will remain the I min. Next it's 4, so we will check 4 less than 5, yes 4 is less than 5, so now 4 becomes a new I min, so we will swap 4 and 5. Okay, so that's why it has been 4 and 5 is swapped. Finally it is these two, so we are checking 7 is the new I min, we are checking 5 less than 7, yes 5 is less than 7, so why 5 becomes the new I min, and finally we are swapping 5 and 7. So that's why 1 3 4 5 7. So the time complexity would be, for each element I'm comparing it with n minus 1 elements. Basically if this is the I, it will compare for the I plus 1 all the way up to n. So if this is I, it will compare all the way up to I plus 2 to n, correct? So it will be the first loop will run up to n times, and the inner loop will run like n minus 1, next time it will run n minus 2, next time it will run n minus 3, it will go on like that. Finally it will be only one time, like that, correct? So it will be the resulting time will be like a binomial expression of a of n square plus b of n plus c, like that. We will simply define as the we'll take the expression with the highest power. So here it is n square is the highest power, so we'll do as O of n square. So the time complexity will be O of n square, and we are not taking any new space, we are just swapping. The swapping also is a constant O of one space, so the space will be O of 1. This is the space complexity, and this is the time complexity. So this is about selection sort.